All right, so when I'm building the ePod prototype, I'm going to use used laptop cells. So it's very good for the environment, and you can get a lot of power for very little money out of these cells. So battery is usually the most expensive part of an electric car. So what I did is I have this Arduino and I test the capacity of each cell. Now once I know the capacity, I arrange them in different groups. So here we have the very strong cells. We have 16 cells that have over 2000 milliamp hours. So that's just about the strength they came out of the factory. I have one here that's 2220 milliamp hours, so that's very strong. Then I have another group here that's the mid-range cells, 1500 to 2000 milliamp hours, the 19 of these cells. And the back here I have the bad cells, 8 cells under 1000. And these actually get really hot when you charge them over 4 volts. So in total I have 43 cells here, and 8 of them I won't be using in the pack, but the rest I will be using to build a larger battery pack. So in the ePod electric car, for the prototype, I probably want about 500 cells. So this is maybe almost a tenth of what I'm going to need. So I take the medium healthy cells and the healthy cells, and I pair them together. And what I do then is you make a pack out of parallel and series configuration. And the amount of packs then that you have in series, that'll give you your voltage. So this is a 12 volt pack maximum. It goes down to 9 volts. So if each cell is at about 3 volts, which is the bottom, it's all at 9, so you have 3 times 3. If they're all at 4, then that gives you 12 volts. So I have 8 cells together in parallel, and then I have 3 sets of those in series. So when I build the pack for the electric car, it'd probably be around 48, 70 volts. It'd be higher voltage. I'd have maybe 14 or 15 sets, and I'd have them in parallel depending on how much amperage I want to pull out of the pack. Here's an example of a battery pack that you could make. You could have 3 cells in parallel, and then you could have 3 sets of these cells in series. So this means overall you'd have 12 volts max and 9 volts minimum. But because you have 3 here in parallel, you have 3 times the amperage that you can pull from one cell. So normally a cell at 1C is about 2 amps for 1 hour. Now you can pull 6 amps for 1 hour. If you pull it up to 2C, you could pull 12 amps for half an hour. So depending on what motor you have and what kind of amperage and voltage, you can switch this pack around. So I could take the same 9 lithium-ion cells, and if I arrange them all in series, I can get up to 36 volts. But I only have 2 amps at 1C. So that I have 3 times less current, but I also have 3 times the voltage. So with these cells, it's great because they have about 1 amp, 2 amp hours for most of them. So that means you can have any multiple of 2 for current, and they go between 4 and 3 volts, so you can use any multiple of 3.5 for the voltage that you need. So it just depends on your application. So that was the extreme for voltage. The extreme for current is to have 9 cells together in parallel. So you only have 4 volts maximum, 3 volts minimum, but you can pull 18 amps out of this at 1C. At 2C, you can pull 36 amps. So if you need more amperage, you can trade your voltage for your amperage just by arranging your pack in a different configuration. Now, what I want to do in this, because when I charge it, different packs will get different amount of voltages, and I want them all to stay around the same, so that means they need the same capacity. Otherwise, one set of cells could be at 4 volts and the other ones could be lower, and that means I'll overcharge one of the packs. I'm going to be able to balance the pack, but I want it to naturally balance as much as possible. So to do this, I have to put the medium strength cells and the strong cells together in the same parallel pack. So that means overall the pack they will all have the same capacity together. If I only put strong cells in one pack and weak cells in another pack, then I'll have more capacity, more power going to one pack than the other, and then they'll become unbalanced.